All right, welcome everybody to week 6. This week we're going to start talking about project management, software versioning controls, and how we can build, or hopefully how we can build a very robust or efficient system for taking projects, understanding them, breaking them down, scoping them, bringing them into, turning them into programming tasks, developing the software, and then delivering it. Today's topics, you'll see that we'll cover the Sdlc, the software development lifecycle, or systems development lifecycle, depending on how you like to look at it. We're talking about software here, so to me, it's the software development lifecycle. We're going to look at the phases that go along with that, and then I want to point out some things like secure software development lifecycle and how you can add in or bake in security into that process, because it's absolutely critical that that happens and that is at the forefront of all phases of planning. It cannot be an afterthought. It cannot be something that you just test for when you're done and you're rolling out the application or you're moving into a QA phase. With that then, probably on Thursday's lecture, we'll move into some of the methodologies. We'll start with some of the classics, the waterfall and maybe the RAD, just to get a review. And then we'll move into more of the modern ones, Agile and Git Flow and the DevOps, and look at where the industry is trending to go towards to support this very continuous release, active release, life cycle that we're seeing. Now, I'll keep in mind that this isn't always the case. Oftentimes we're going to have people that work at organizations that they don't generate or produce projects on a weekly basis. They maybe push out releases once a month or once every couple months. And so while some of these more modern workflows, or the ones that are really in vogue right now, are geared to that continuous life cycle and always pushing things out, that's not always the case. But studying them, and from a lot of your guys' feedback, it sounds like everybody kind of adopts their own hybrid approach. They like to take a little bit of classic waterfall and mix in a little bit of agile, and they make it work, and they make it very effective. So, ultimately that's what I want to get out of it, is just how can we, what's out there, what are people doing, and then how can we leverage that to better manage our own projects internally. As far as D2L, okay, so last week I had some hiccups. I was at a conference for the military, and I just didn't have the internet that I was expecting, so I had a hard time getting anything uploaded from my hotel Wi-Fi. So the task for the Thursday that I posted was to go to GitHub and check out the challenges. So if you're not familiar with Git or GitHub, that's really what this is designed for. You go there, get just a basic understanding of how it works, because that's what I'd like you to have, because we are going to use it for essentially what will become our next labs, if you will. We'll use Git, and we'll do some project management type versioning control with an actual software application that I'll put in there. With that, I'll need you to send me your GitHub user account. So if you could send that to me by Friday, just send it to me in email. Then that way I can I'm going to have a repository for our class, and I'll get everybody added to that, and we'll get some initial commits in just to make sure that everybody has access and that we're all set moving into the following couple weeks. So please get those to me by Friday, and I'll get you added to the repo so that you can have that. When we get to talking or actually working with Git, I'll do some more demos. I'm going to go on the assumption that most people aren't familiar with it, or that you guys aren't familiar with it. But if you are, when you send me your username, if you want to just tag in there how familiar you are with it, to absolutely never heard of it before, or I kind of understand what it is, but I don't use it, to I use it on a daily or weekly basis. Just kind of let me know, to give me a heads up. You could also tag in there any other version control systems you're familiar with. Okay, if we have any Microsoft devs out there, maybe TFS, Team Foundation Server, SVN and CVS are pretty popular. Obviously, if you have no idea what I'm talking about, then we'll get there and we'll cover those, and we'll show you that bottom line, versioning control. We want to maintain control of our code. Additionally, in the content section, we're going to have a reading for this week. It's just going to be this PDF, and it talks about requirements documents, and these are again, just kind of gauging from some of the discussion that we've had on the discussion boards. Documentation is something that is very often overlooked, and I can tell you from my experience as well, the only time I've really had really good, thorough, robust documentation is from a business that I worked at that had a team of project analysts, project managers, because it was their job to do that. But them being able to do it provides a pretty large, significant, positive impact to the overall project. So, browse through this document. It's not very long. It was written by, I believe, a grad student, and it's even kind of old, modified 1999, so it's even 10 years old, but the ideas are the same. you know, and we'll talk about the requirements document a little bit just because how important I think they are. So let me just get that uploaded right now so I don't forget. Okay, and if I find something better, I'll just delete that, and you'll see another document in here that's, you know, clearly labeled something to the effect of requirements. Okay, so here's our reminder. Go to github.com and set up your account. Just go there real quick. What you're going to see is I probably already logged in. I'm usually in GitHub on a daily basis. So you go to GitHub and you can see I am logged in. Let's see, there's a logout function. So this is it. Pick a username, send in your email, and then create your password. Okay, your username is what I need in order to add you to the project, order to our repository. So once you get that set up, from there you can do whatever you want. If you follow this tutorial, you'll be able to create repositories and push and pull and commit and all that good stuff. I encourage you to do that, but if you haven't done it yet, you know, don't worry too much. We'll go through a little bit in class, and then we'll use it more in the next, you know, like I said, lab or whatever we're going to call it. Okay, what is Git? GitHub is a website. Okay, we were just at github.com. Git is the technology's version control, and it provides, I use Git, again, I think I use it on a daily basis. It provides me with version control, it provides me with release management, and for a platform like GitHub, it can actually provide me with something for project management. At my last job, we use GitHub and kind of a Git flow for all of the above here. Version control, release management, project management. We can use it to branch, we can use it to assign features or to assign tasks to programmers, and then they can, working on the same code base, take, you know, and branch out and then work on their own changes. Once they're ready, they can pull it back into the master line, and it helps to then, you know, keep us consistent on one code base so that everybody always has the latest changes that are pushed or that are out in the production servers. It has a wiki, so it's a great place to throw documentation, and then it also has an issue tracker. Okay, it's not necessarily the most robust. You know, it all depends on your application. Sometimes you're going to need applications that support issue tracking being submitted from a call center or from a user form or something, and GitHub doesn't necessarily facilitate that. But from the developer's perspective, issues that are coming in for your product, they're probably going to get caught by somebody other than you, the people using GitHub, the actual version tracking software. They'll probably come from that call center, that customer service rep, whoever it is, and they'll land on the desk of the manager. And then the manager will say, we have a task. I'm going to create this issue, put it into our issue tracking software, which may be something like GitHub, and then assign that out individually to a programmer. So a whole bunch of stuff there. And we'll go through all of that, kind of through that life cycle here in within the next few lectures. And that was GitHub. So Git itself, okay, I'm sorry if I just blended the two. Git itself is really just simply the version control software. So if you have a Linux system, I think Git comes just installed by default, and it is predominantly command line driven, although there are a lot of GUI, graphical user interfaces, front ends, and we'll take a look at a couple of those. And it just allows you to track changes, track your code. You know, I branch, I create some code take some code from the repository, I make a bunch of changes, I use Git to commit those changes, I push the commit back to the repository, and now we can track those changes. So on an individual basis, that's not necessarily that big a deal, but when you work in a team environment, especially as you as a manager and you want to see how everybody's doing, and look at the kind of commits they're having, look at their code, maybe somebody pushed out a bug, you can use this version control system to track down where that bug was introduced, and then get into figuring out why was it introduced. Maybe some of your programmers need some education on, you know, doing something correctly or incorrectly. Maybe it was just a simple, honest mistake, and there's no real education other than, hey, you made a typo here, or you just weren't thinking. So at its core, it's versioning control. The release management, the project management, those are things that a GitHub, a platform that utilizes Git, adds on to it. Git was developed by Linus, I'm not sure how he pronounces his name, Torvald. He's the guy that created Linux. And so it's used, it was originally designed to manage and develop the Linux kernel. So I figure if it's good enough for that, it's probably good enough for most of my projects. All right, so before we get into project management, we need to start kind of big picture and talk about the software development lifecycle. Okay, again, SDLC, software development lifecycle, or well, I said the same thing. Oh no, I'm sorry, software or systems development lifecycle. But we're talking about software here, so I like to refer to it in the context of the software development lifecycle. What this is it's our way, it's the process that we take in order to identify how our software systems, what we're building, and this can be bigger, right? This can be systems, this can be IT processes, this can be anything. We're just going to narrow our scope down to the software that we're developing. But how do we support business needs? How do we design the system to support those business needs? How do we build it? And then how do we deliver it to our end users? Whether those are internal, whether those are external, whether it's a combination of the two. This is this process then is kind of the overarching, the basic underpinnings for the different project management life cycles that we pick. Waterfall will include these phases that we talk about in SDLC. Agile, continuous release, Git flow, all of them. They all base from these four kind of main phases. But again, as we see for the conversation and probably from personal experience, you'll be hard pressed to find anybody that is just religiously follows these processes to a T. Most people are going to say, well, we kind of like to use this cycle or this project management, or this is our SDLC, but we varied here, we hybrid here, we modify here. So this is just trying to lay a good solid foundation. We're not going to get into too much detail here because I assume, now that we're all at the grad level, that you took some sort of a software development lifecycle course. So anybody that came through DSU for their undergrad, systems analysis and design, a lot of this information was covered in that semester-long course, and that's how important it is. So hopefully most of this stuff is just kind of a refresher here for today's lecture, but if it isn't, again, let me know, or I can point you into some, some resources to build that better background, or there's a lot of stuff out on the web, of course. Why do we have an SDLC? Why do we care about this? Why do we try to define a formal process in order to ensure that we deliver? Well, as managers, a lot of our success is going to be gauged on how well we deliver a project. So it becomes very, particularly important for us that we have a way to do this successfully, that we are successful, that our team's successful, because oftentimes when you boil everything down to the basics, down to the bottom line, our jobs depend on it. This is a very, very difficult thing to do. Many systems, okay, and I'm using a different text here that I don't have out there, so that's where I'm sourcing this. Again, if you're interested, I can give you the ISBN or something, you can pick it up. But many projects are delivered significantly late, they cost more than expected, and they have fewer features than originally promised, originally scoped. Now again, not everybody has that same experience. Some of the feedback we got from the discussion items are, one of them was that they have a good project management lifecycle, whether it's really formally defined or whether it's just something that is evolved as they have worked together. It's hard to say, but most projects that I've worked on fall, unfortunately, into more of this category. And there's a variety of reasons why I think that. Some of it I do think is a lack of PM. Some of it I think is a lack of communication. Some of it's a lack of expectations. But all the issues boil down into the things that we discuss when looking at the SDLC. So that's how I propose that we fix it. Again, I'm not proposing here that everybody has a thorough, robust, well-documented, well-implemented, every step, every process, every possible contingency type plan, but the more that you have in place, I think the more successful, the odds of success will be greater that you'll experience as you're going through the different projects that you work on. Okay, this is another one of those topics that really has no silver bullet. Okay, so your personal experience will probably be what guides you the most along the way, and so hopefully, if you don't have a lot of experience doing project management or a lot of variety, then this will just help give you some of those basic tools, some things to look for, some starting points, so that when you're in that role, or if you're currently in that role, you can change it for the better and make it for the better. So Who is typically the key person in the SDLC? Well, if you look at a formal definition or a formal setup for an SDLC, you're going to probably have some sort of a systems analyst. Somebody that's dedicated simply to the management of the projects. Now, that's true in an ideal world. Okay, again, from your feedback, most people probably don't have dedicated project managers or a team of project managers. I've been fortunate. I've worked on a team that had a group of project managers, as well as quite a few teams and quite a few environments where it didn't. No project management at all, in which case then all the project management fell onto me. Additionally, I've spent the last 10 or 12 years as a consultant and a freelance developer, in which case it's just me, right? And so with that, I've had to take the responsibility, the burdens, the good and the bad, of project management on myself. And so it's something I've been doing for a variety of years. And as with most things, I develop ways where I don't follow all of the things that we talk about because I'm just a one-man shop in my consulting role, but I do a lot of it. And I've learned over the years that the more I document, the better I formalize my process, the easier it makes my job as a consultant, even though it takes a little more time up front. So the bottom line with the systems analyst is that a lot of companies are going to have one. They are going to have a dedicated individual or a team of individuals because the skill set that they need, it can greatly enhance the project. When we start talking about that skill set, I think you'll see that there is a very large amount of it that's going to be a direct overlap from our discussion on talking about successful leaders. So systems analyst, project manager, or you ultimately. If you're the manager, if you're the team lead, and you don't have any of these other positions within your organization, then obviously this role and responsibility falls onto you. If you're a one-man shop, this falls onto you. Even if you're not the manager, if you're just the only developer, you need to also be the systems analyst, the project manager, to make sure that you are delivering your projects on time, because again, that's going to be a large part in how your success as a developer is going to be measured. What's the overall goal then of this role? Is it to develop a wonderful, perfect, flawless system, or to deliver value to an organization and the customer? And I would say it's the latter, right? We want to deliver something of value. If we can deliver a wonderful system in the process, that's great. That's awesome, and we want to do that. But oftentimes, delivering something that works flawlessly and delivering something that works really well, they can be two different things. And to deliver that system that has every feature and every bell and whistle, or the system that starts generating revenue, you're going to want to start generating revenue first. And so it's important that this position, okay, again, probably it's going to be an analyst. It's going to be you and me as the lead or the manager. We need to keep things in perspective. We need to understand that yes, we can develop a perfect, well, not necessarily perfect, but we can deliver a system, a program that's very feature rich. But how does that impact overall effort? How does that impact our timeline? And let's make sure that we deliver the product we need at the time that we need it. So this role becomes largely, how timely can we be? How timely can we make our teams? So what makes a good system analyst? Okay, this is where I said I think a lot of these skills, if not every single one of them, are going to overlap directly with our conversation on leadership. Have the technical skills. Okay, so we talked about technical credit, technical merit as a manager. Same thing's going to apply with an analyst. Okay, if this is you, if you're the analyst, if you're the PM for your projects, well, you need to understand the platform. How can you manage a product if you don't understand it? That doesn't mean that you understand every single line of code that your developers are writing, but you understand the technology enough to know where are you heading with it. Where is the industry heading, and are you guys going in the right path? Are you on convergent paths or are you on divergent paths? If your business came to you and said, "Hey, we want to develop all of our platform on Cold Fusion," that would probably be a bad idea, right? And you, as the manager there, you should be able to recognize that and say, "No, that's really not a good language right now because it's just not. It doesn't have the traction that it used to have in the industry." You need to have business skills, okay? And sometimes this can be the hardest thing when you move from maybe a mid-level to entry-level programmer into that management role, is that your focus can't just solely be on the product, right? It can't just be on the system. It has to be on the business, and where is the business heading? What is the business doing? What are they trying to accomplish? And what brings in the money. I mean, that's really what it comes down to. And so your view as the analyst or as the manager needs to be very broad. You need to understand how this product fits. How does it provide value for the organization? And is it what the customers really want? Because if you're missing the target on that, you can build the greatest platform in the world. But if you can't get people to, if it can't get it to generate revenue, then what good is it? Well, I mean, there are projects that don't generate revenue that are good for companies, but typically speaking, you need to be able to communicate. Communication is huge, and with this role, again, where this becomes challenging is that you need to be able to talk to your devs, or maybe you're a developer yourself, so you need to understand the nitty-gritty of the language, the technical aspects of it. But then you also need to be able to communicate with that C-level executive, with the project analyst, with maybe you're developing software for a call center. You need to be able to talk to the call center rep that has to use your product. You need to be able to communicate at every different level and understand that and convey, not only take what they're telling you, if they're telling you requirements or giving you feedback, and turn what they're telling you into something that can improve the product, but also taking what you guys are doing, the limitations that you run into on the technology side, and communicating them out and say, well, I know what you're asking me to do, but it's not possible because of this. So I threw this one in there, conflict resolution, and oftentimes when you're bridging all these gaps, you kind of become the focal point for a lot of different business needs that are relying on you to develop a product to fit that needs. And so sometimes tensions can get high. Other organizations within the organization proper can say, no, my project is more important than so-and-so's project. And so it comes up to you to help communicate and determine and assign priority. Fair, honest, and ethical. And that's just a good trait for people in general, but again, you're going to be dealing with a lot of people. And so how you interact with them, being fair, being honest, being ethical, will be critical. What are the roles? Well, they're going to focus on the issues surrounding the system. Well, again, how can we improve the business process? How can we create efficiencies? How can we create market share? How can we get customers? That has got to be one of the big focuses. It's not let's develop technology for technology's sake. Let's improve our business. This role also, you're in a very key position because you understand the technology and what can be done, and you understand where the business is heading. You can identify and help create new business processes, and that has got to be something on your mind. Don't get just bogged down in the business is just pushing down all these requirements, all these projects on me, and we're just trying to put our heads down and get through these projects and roll them out the door. Also stop and think, what are ways I'm looking at these processes that are coming from me, and I know it better than probably anybody else, so is there room for me to improve that? Ensure standards are maintained, okay? And this is going to become big because this is where, in this role, you have the ability to say, especially as the manager, to say, well, we are going to generate documentation, we are going to do code reviews, we are going to QA our code and run it through a QA process with independent testers. We do have a secure software development lifecycle, and I am going to look for that when we do code reviews. Code reviews cannot be done by the same person. You can't code review your own code. That doesn't make sense. And so this is a point where we can help maintain that. Requirements documents aren't going to come into, go to my developers unless they actually make sense. They eliminate as much ambiguity as can be eliminated. And then they also often drive the quality assurance or the QA of the code. And I actually want to spin this off into a separate topic because this is another one of those areas where I've worked in several environments where QA is just kind of dubbed as or viewed as not quite that essential process of the software development lifecycle, even though developers were consistently pushing out code that broke. And you will spend more time scrambling to fix that broken code than had you just pushed it through a robust or at least a thorough QA process before getting out the door in the first place. So we'll look at that. We'll also look at unit-driven testing here towards the end of the semester, which will really, the full focus there will be QA. Okay, talked about earlier, there's 4 phases to the software development lifecycle, and that's these top 4 right here: planning, analysis, design, and implementation. Okay, so we're going to take a quick look at each 4 of those phases, and again, really, I'm expecting this to not be new information for you. So I'm going to gloss over a lot. There's a lot of very important topics that come with each one of these that we're just simply not going to cover today, just because we don't need to. I don't think don't need to take the time. This last one isn't really a phase, but it's that product success. Okay, we've released something. We've released our product, or at least a version of it, or a feature set of it, and now we need to figure out, was it successful or not. And again, I think we talked about this in the last lecture, the one right before it, in measuring success, getting feedback. Project completion and project success aren't necessarily the same things. For each phase, we're going to look at requirements and possible deliverables. And that's just to give you an idea of, with each phase, what kind of activity is going on, and what should the user, what should the person get, possibly see as a deliverable from each phase. Deliverables are important because they help set the tone for the project, and they help hold people accountable. Okay, if you get into very agile methods and you say that each week we're going to have our Scrum, right? We're going to get together, and that's part of our project management lifecycle. And our deliverable from the Scrum, or going into the Scrum, is that every programmer shows up and they talk about what they're currently working on, and what's blocking them from getting their work done. That way, when they bring up those blockers in a group setting, maybe when other developers run into that same issue, you can say, hey, I worked with that 6 months ago, and this is the solution, and that person can get past that blocker a lot quicker. This looks like a very linear process, and if you think of, I think probably we can all conjure up this a graph of a waterfall method, and that one method flows into another, that flows into another, that flows into another, that eventually flows into project completion. It's not necessarily, right? A lot of the agile methodologies that are out there are much more circular or iterative, and that we do a little bit of this, and then we start over, and then we do a little bit more. And so we'll take a look at each one of those in turn here on Thursday. Okay, so starting with the planning phase, a couple of techniques, a couple of things that you're going to be looking at in planning is potentially, again, this is a very small list of a possible list of, just a very long list of possibilities. So project identification, technical feasibility, economic feasibility, and the project staffer. So we got to identify the project in the first place. What is it? What needs to be done? Is it really a project? Is it feasible or not? Is it technically feasible? Okay, we need to do that initial kind of research into this potential project to make sure that it's even worth spending our time. The last thing we want to do is spend a whole bunch of time working on a project, scoping it out, doing research, assigning people to start doing the work, maybe even doing the work, just to find out that there is a piece of it that's just technically not feasible. And then you end up having to scrap a whole bunch of effort, or considerably change the scope of the project when you're already into the actual implementation of it. Some of the deliverables that you can have in this, okay, again, it's no hard and fast. These have to be deliverables. They're just ideas to give you something so that if you want to help to either implement or refine an Sdlc in your organization, these are some things you can ask people to deliver during these phases. The system request, okay, formalize. You want me to work on something? Here's a document you can submit to me to help me understand what you're after. And that doesn't always help you. Oftentimes, that the person that's coming to you with the project, you can put questions, you can put into this form for them some probing questions to really help them think through the project, think through their ideas, and do some of that preliminary research for you, so that they don't come to you with a project that's maybe just simply an idea to them, and then essentially waste a bunch of your time just to find out that, yeah, it's not really a project, it's just not technically feasible, it's not economically feasible. Okay, the idea here isn't to create bureaucracy. Okay, and it's sometimes, it maybe sound like that. I don't want you to have. I'm not saying go back to your organization and say, okay, you got to submit a form in order to request a system request document, which then I will send to you, which then you will send to the Office Space example. That's not the idea. The idea here is, though, to use these deliverables, to use documentation when it helps, when it really does help. And sometimes a system request document can actually help. Feasibility study, right? Some places you're going to have to do those. I don't think I've done a single one as far as feasibility. Well, you do, I guess you do and you don't. Every project has to go through a feasibility test. I have to think through it, whether I document it or not, to say, yes, I can actually do this, or no, I actually can't. Because the last thing I want to do is commit myself or commit my team to a project that they can't finish. I set them up for failure. Project plan, work plan, yeah, I mean, a potential deliverable. You start to define high level. What is the project? What's it going to entail? And what would we consider a successful project? Staffing. How is this going to impact my team? How is this going to impact my resources as a manager? Okay, all things that need to be thought through. Again, is this thing feasible? Is it really a project? And that's what we need to be thinking about in this early first phase. Moving into analysis, then, what you assume when you get to this phase of development is that you have a good idea, you have a good project, it meets the technical feasibility, it is economically feasible, you have the staffing, you have the resources, you have the technical know-how and expertise, and now you can really start laying out your plan. Use case analysis. Okay, these are going to be important for developing your workflows for the product, the software, the pages, the functionality that it's going to contain, as well as to help you QA the product as well. And so we'll talk about use cases a little bit more here later in the semester. You can also do data flow diagramming and ER modeling and normalization. And I think these things are tremendously helpful. They're time consuming, they take effort, they take work. But you know what? The thing is that you have to do all this. Whether you do it up front and turn it into a formal part of your project management lifecycle, or your developer has to do it on the fly as they're developing the application. It has to be done. And if you don't do it, then the developer has to do it. Someone has to sit down and actually flow these things out. If your application uses a database, if it stores data, well, you have to create a schema, you have to create tables, you have to create columns. So doing this in advance can help the developer out tremendously, because then they don't have to spend the time doing it, or it gives them something to build off of, and they can start right away with implementation and then modifying those schemas as they work on the product and realize that things aren't exactly, I mean, nothing's ever going to be 100%. You're not going to be able to create a data flow diagram that is 100%. You send it to the developers, you enter the implementation phase, and it's just going to work. No changes are going to be required. That's not probably going to happen, but it gives them a great resource to start with. Wireframes, right? Set up wireframes. You're building a web application. What pages do you want? On each page, what is the functionality that you expect? And these not only help the developer because it gives them a blueprint to build from. Think of these as blueprints, but it also forces the person that's coming to you with the idea to go through that same process. I want an e-commerce application. I just want to be able to sell something, and nothing big. Well, okay, that's true, but if you need to be able to sell things, then your users need to be able to log in. If they need to be able to log in, then they need to be able to look at their profile. They need to look at their profile. They need to be able to look at their order history. What if they forget their password? They need password reset functionality. When the application detects they're trying to check out, but they haven't created an account, it needs to redirect them to create a login account. There's all sorts of things that when you start to map out the flow, all of that comes out because you're trying to go through the normal use cases of an application. Normalization is good, and that it looks at, if it's been a while since you've looked at it, that's your first form, second form, third form, fourth form. That's just how much, how do you structure the data so that it makes sense? And a part of normalization is trying to eliminate some of the redundancy in the data inside of the database itself. So, again, normalization will have an impact on maintainability and how the code is actually structured. So what are some deliverables here? System proposal, requirements definition, use cases, data model. Okay, these data flow diagrams, these CR models, these things can become great documents to pass off to the development team so that when they start implementing, they have the blueprints to build from. Okay, here's an example. If we go back to the requirements definition, not a full-up requirements document, but a requirements definition, you can see here, functional requirements. Okay, and this is for a car sale, a system that sells cars. Okay, new vehicle management. So we're looking at the functional requirements for this application for new vehicles. Okay, what does it need to do? The system will allow managers to view the current new vehicle. The system will allow the new vehicle manager to place orders for new vehicles. The system will record the addition of new vehicles to inventory when they are received from the manufacturers. Okay, high level, right? This is the requirements definition. It's not necessarily a requirements document. This gives us a good idea of what we're building, but let's look at bullet 1.1. The system will allow managers to view the current new vehicle inventory. Again, what does that include? Well, if we back it up and look at the entire application, okay, managers. Okay, so we have to have a login-based system. We have to have roles. Okay, managers, administrators, general users. Who knows? They need to be able to view the current new vehicle inventory. All right. Well, we need a data model. We need to know how those vehicles are being stored in our database or through an API somewhere. We need to define the interface itself. Okay, when we show a new vehicle, what does it look like? Is it just a listing with VIN, make, model, year? Does it have miles? Do they need to be able to click on that and have a modal or go to a second page? While this is a great start, you can see there's still a ton of implementation details that me as a developer, I still need fidelity on. So you start with the functional requirements document, and then you nudge it down, and you actually have the requirements document itself. And I'm sorry, not the functional requirements, the requirements definition. And then you narrow it down, and you say, okay, these are the actual requirements that I need, and it spells all that stuff out. Okay, this page to view new vehicle inventory will be only allowed for the manager's role. And somewhere in the document before that, I'll say these are the roles that are going to be created inside the system. And with these roles, they can access this functionality inside the application. And then if we wireframe it, okay, you can see, well, this is the view new vehicle inventory page. And on this wireframe, we will lay out all of the information. A wireframe can go a long way in conveying a lot of information to someone just simply using those diagrams. Here is something that I generated for a client. You can see it's a little dated here. I'm lazy. I didn't want to go and blur out all the numbers, so please try to ignore those. But the idea here is that this is a very high-level requirements document. You know, I don't have time as a freelancer to go through and create something like this. This is time-consuming. I understand that, and so I create things like this. And I say, I'm going to create an HTML-based template. I'm going to set up the software. I'm going to ensure payment gateway is set up. I'm going to do some SEO optimization. Here's delivery. Here's beta test. You know, and I still, in a very high level, I break out the requirements, but this right here isn't really saying a lot. But because I'm a one-man shop, this says everything to me. I know what I need to create here, and so I can lose some of the fidelity in my requirements document because this is what my customer needs to see. They're not as concerned about this as they are about these numbers over here. Okay, third phase, design strategy, hardware, software selection. Okay, maybe that doesn't matter, maybe it does. Web application, what kind of servers are going to be running on it? Do you have the software to support it, or are you going to put it out on a cloud-based software as a service solution? Put it in Amazon, put it in Rackspace. What is your end user going to be using? Are they going to be using the browser? Okay, well then what's our target operating system? Is it Internet Explorer? Is it Safari? Is it Chrome? We want to start looking through and refining those user scenarios, use cases, and then really focus on the interface itself, the structure, the standards, the prototype, and the evaluation of it. Okay, we need to work on that with the wireframe, and we need to further refine it in the design phase to have a very robust product. Deliverables, potential, system specs, program design, physical data model. Okay, just some documentation to help along with the design process. Design phase, if I'm a web developer, I oftentimes am going to get some sort of a mock-up, you know, a Photoshop file or a series of images that tell me, you know, this is how I want the site to look, these are the colors I want it to use, these are how I want the font sizes to be. If it's, you know, mock-ups associated with the wireframe, then maybe I'll actually see how, here's that grid for those new vehicles, and this is how I want it to look. Or if the customers are looking at the site, this is how I want to show them the vehicles. Okay, implementation then. This is where we actually start programming. Okay, so programming it, we develop the solution, we develop the software, we start testing it. We test it for bugs, we test it for accuracy, we test it for liability, we test it for security, we do input validation and input testing. Can users send malicious things into my application that affects or compromises the security of my other users or of the data that I'm holding and processing? Performance testing. Right? Maybe we got a great product and it looks good, but it doesn't perform worth a hoot. You know, if it's a web-based solution, client server, right? People have high expectations of how responsive an application should be in a browser now, and so that needs to be a part of this implementation process. And then training. Okay, you roll your product out, and who's your target audience? Okay, is it internal? Well, then maybe you need to have some training because maybe it's a version 2 from a version 1, and version 2 is just a complete rewrite, so it's completely different. Some possible deliverables here, test plan. Okay, test plans are good. We'll talk about those later. Any sort of documentation to support the system, migration plan. Maybe it's, maybe you're rolling out a CRM. Maybe you built your own CRM and you're migrating users from Sugar or Salesforce or something. I don't know. Support plan and problem report. Okay, so how do you get feedback from your users? How do you identify issues in the system, fix them, get those back to your developers, and get those issues fixed, and back out into the production server? And then how do you support? Are you prepared once this goes live to support? Maybe it's going to be open to the world. And can you support people that are going to your application and saying, yeah, I'm having issues. I can't log in. I can't reset my password. I can't do this. And those all need to be considerations so that the project will be successful. Okay, not just delivering the project, but the ongoing support of the project as well, or the software as well. Okay, so secure software development lifecycle. I think we could spend a good deal of time on this if we really wanted to, but I'm just going to kind of gloss over it for right now. Well, not gloss, but just kind of give an introduction of it. And I will reference largely OWASP.org, and we have the OWASP Guide Project. Okay, and we'll go visit that in just a second here. And what I want you to think of when you're looking at the secure software development lifecycle is how can we include security in the Sdlc? And what I say it comes down to is you must be proactive. And in order to be proactive, you need to understand the issues. If you are developing web-based software, you have a very unique set of issues. The browser, the client server model, HTTP, TLS, SSL, there is a lot of things you need to be aware of. And so you need to understand those issues, and then you need to be proactive in making sure that the application is tested for it, the issues are resolved, that they're fixed, that you can identify them, and that the developers have a good idea of the security issues going into the original development of the software itself. We don't want to find security issues in the QA process. We want to stop them in the beginning by writing good, secure code. If we catch them in the QA process, that's great. Then we need to be able to log them, track them, and get them fixed, and also hopefully educate our developers as to why that is an issue. Personal experience, I've worked for quite a few companies, well, I shouldn't say quite a few, but enough companies where some of the most basic security issues that are dealt with in web applications, some of the other developers didn't even know. And I will admit, I didn't know a lot of them coming out of college. Where I went to college, we didn't talk a lot about secure software. And so I wrote a lot of really bad code right out of college until I finally stumbled across the right people to say, whoa, you need to write better code, and this is what you're doing wrong, and this is how you fix it. We need to be educators, advocates, right, on our teams with other developers, if there are developers, the QA, okay, people that do QA for the site. They need to understand, and this is critical, they need to understand how to, because oftentimes what I see with QA is, well, does the site work? Okay, they go to the site, they type in just kind of the normal user flow, and they say, yep, works great, I didn't find any issues. They didn't test your site for security, they tested your site for usability. And so we need to have a very focused effort to test it for security vulnerabilities as well. And there's a whole bunch of things you can do that. You can hire teams that do application pen tests, but it's best to develop that in-house or have that experience yourself. Managers can do that, right? Managers can look at code through testing the product, through doing code reviews. They can help point those things out and be a proactive part of this, let's educate everybody to write secure code. It's a large undertaking, okay? And so it just is it's something that you have to understand, you have to be proactive, and you have to be willing to educate people on. One job, for example, that I was at, one of the things that I did, because security was critical for us, but it wasn't something that was always talked about or on the forefront of our software development lifecycle. So one of the things I did is I tried to raise awareness, and once every, I think, 2 weeks or once a month maybe, I would put together security-focused demos and talks on Friday afternoons for the development team and anybody that was interested. We talked about things like cross-site scripting and SQL injection, just to get everybody at least get their level of knowledge and understanding up to a pretty high baseline. Let's see, so understand the issues. If you have no idea where to start, I highly encourage you to go to the OWASP Top 10 2013. Okay, so if we go to, oh, that's not it. Here it is. Okay, so if we go to the OWASP Top 10 2013, just search for it. If you get to OWASP.org, you can see here's the top 10, and it takes you to Top 10 2013, and there's a variety. The wiki, I think, is kind of poorly laid out because every once in a while I have a hard time figuring out how did I get to the actual top 10 list that we were just at. So top 10 here. And here it's going to lay out the top 10. Again, by no means an inclusive list. There are top 10, there's top 20, there's top 200, there's top 500 vulnerabilities list out there. But what this does provide is a good place to start. So if you're not familiar with a lot of these things, come here, take a look at them. Look at injection, look at cross-site scripting, especially if you're dealing with web. These aren't exclusive to the web, even though it's the Open Web Application Security Project. But some of them will be. Cross-site scripting is really just a web-based, browser-based problem. Go through here, though, and make sure that these issues are being identified. If you look at some automated pen testing tools for applications, I just got through some training for core security, the core impact tool, which is a top of the line pen testers tool, and they test for, when they do applications, they test for the OWASP top 10. Okay, so it's a good place to start. It can also be leveraged as a tool to educate developers, to say, oh, are we looking for injection? Maybe I don't understand injection, but I know enough to know that it's a problem, and I can at least bring those questions up. Developers can then look at them. They can say, oh boy, I really do need to know about injection. They can come here, and if anything else, it's just as a place to start. Do you know what injection is? When you contract with third parties, okay, same thing. If you can at least know the right questions to ask, well, how does your application, how does it handle injection attempts or broken auth? How is the authentication and session management handled? This helps you to ask the right questions to know that you're getting a product that has some quality development behind it. Let's see. So that's the top 10. What is my... There's also the OWASP Guide project. Okay, so if you come to the OWASP Guide project, you'll see over here, this thing's kind of in beta. So they had a better product, but it was very dated, and so they're rewriting it, and in the process of rewriting it, it's lost some of the content as it's being rewritten and made modern. So if you go here, this thing's out on GitHub, and you'll see that developer guide reboot, so it's definitely in reboot. You want to contribute, okay, yeah, I actually am contributing to another one. But here are introduction, design, build, operational security, right? So here's a place to start. It's not complete, but it does give you some ideas for, we're working in an application and we need to deal with cryptography, or we need to deal with session management. So let's pull up the session management portion of this guide and look at types of attack vectors, using a framework, elements of secure session management. So these are all concepts then that can arm you to say, this is how, in a secure application, this is how we handle session management. Okay, so that's the idea behind these guides. There are other projects, other guides out there as well. There's the code review project. Okay, so if you don't have a code review process, great place to start. You probably should have. Again, it all depends on the size of your shop. If you're a one-man show, it's pretty hard to get code review going. But if you have a team of 5 or 6, it's a good idea to have a code review process. Not only does it help developers learn from other developers, it helps catch bugs, and it can add an element of security. When I worked at a credit card processing place, all my code before it got released had to be code reviewed by somebody else, and they had to sign off on it. And part of that was to make sure that I wasn't pulling office space, that I wasn't trying to siphon off 1/10 of 1 cent for every transaction. So there's even that operational security aspect that can come from the code review. So from there, you can come through here and you can get a good idea of how does a code review look, how should you structure it, and when you're doing a code review, what should you be looking for? This is actually a project that I'm contributing to. So if you look at this, hopefully one of these days you'll see some of the content that I've written for that. Application Security Verification Standard Project, right? So it sounds like a big, long, and pretty confusing name, but it's a way to help you measure the security in your project. Okay, so again, OWASP is a great place to start because they provide a lot of documentation and resources to help get you on a secure development path. Okay, so let's get that out of there. All right, last thing I want to say here is just the overall deliverables, the documentation. Um, it needs to be done. It's hard, it's time consuming, it seems relatively unimportant, but it does have a very big impact. Again, this depends if you're small, if you're large, but even as a single man shop, oftentimes I create a fair amount of documentation for every contract I go into, because the documentation allows me to document my expectations and the client's expectations. It helps me to define and have in writing the scope of my project, what I'm going to work on, what I'm not going to work on, and how long I think it'll take me to do that. It drives my feature sets. Maybe I will develop X, Y, and Z, and I'll deliver one in 3 months, the second in 5 months, and the third in 6 months. For our teams, right, it helps them to understand, for us as managers, it understands what's expected of me, so that I can break those things down, put those into those feature sets, and then assign them to the team members. And then it clearly, or hopefully, clearly communicates to them what they're expected to build. We've set expectations, we've defined scope, so hopefully it can trickle down to them so they know exactly what's expected of them. But like I said, it's time consuming. It's oftentimes overlooked, or it's not done. It's kind of not given the attention, the effort that it deserves. And it's because everybody's busy, and you've got 8 hours or 9 hours in a day, and you've got about 12 hours worth of work, and the last thing you want to do is documentation. So, I realize that, I understand it, I've been out in the world, and I realize how easy it is or how busy everybody is, but I would just strongly encourage you to take the time to develop those documents that truly do help you do your job better, because they will pay off. Thursday, then, we're going to start looking at methodologies. We're going to go through waterfall, RAD, real quick. I'm going to spend more time on Agile, and then continuous delivery and Git flow. And this is where we'll start to use GitHub and Git flow to talk about and actually work with some project management, code versioning and things. So if you have any questions on Git or ever run into any issues there, let me know. Please, again, send me your username by Friday so that I can get everything set up for next week. And if you have any questions, let me know. Otherwise, I will talk to you guys Thursday. Thanks.